Good afternoon, everyone. I hope you had a refreshing lunch break. We are now ready to resume our session for third day of the online STTP on essential Python libraries for machine learning, data visualization, and data analysis. We once again invite to Dr. Meghna ma'am and all the participants. So let's begin the next part of our session. Over to you, ma'am. Thank you.
Thank you, Ria. Okay, let's continue with the remaining topic. Okay, first we go through the just thoroughly that what we have covered in an earlier session, and that we are going with the next one. Okay, so I'm just presenting my screen. Ma'am, can you stop presenting your screen? Ria, ma'am.
Yes, ma'am.
Can you stop presenting your screen?
Yes, ma'am.
हेलो हेलो
Yes.
हेलो हाँ मैम स्टार्ट कर दीजिए
Ma'am, I'm sharing my screen, but already you have shared your online STTP brochure. That's why it's showing me. Okay, can you see my screen? I am sharing here. Is it visible?
यस मैम विजिबल
Okay, thank you. Not an issue. Okay, just go through the thoroughly that what we have covered in our earlier session that I'm going to tell you. So first we are today the topic is a feature engineering using the pandas. So that we are going to cover in our next lecture also. But earlier we have seen the life cycle of machine learning. What is data pre-processing? Okay, what do you mean by data pre-processing? Then what is feature engineering? We have completed the then then in data pre-processing, there are 5 steps are there that we have covered: data cleaning, integration, reduction, transformation, description, right? And then after we have gone with the what is feature engineering that we have covered in our lecture. Okay, then after we have seen variables, types of variables. Okay, then we have gone through the different methods which are dealing with the missing value. So in that we have seen 2 methods practically: ignoring missing value for the row, delete row, and we have seen one more, measure of central tendency. It means using the mean median mode we are filling the value. That we have covered practically. One more practical we are going to cover in data cleaning, that is we can do the missing value, fill the missing value using the scikit-learn. Okay, so that is the easiest way to fill the missing value. We have seen already 2 practical. One, data cleaning through deleting the row and columns. Second way, we have filled the data using the mean median. And this is the third way we can do the data cleaning. It means we can missing the value imputation using the scikit-learn for the numerical and the categorical variables. Okay, so let's see here. Just a minute, I just minimize it. Okay. Okay, let's see here the how to use the scikit-learn to fill the data. Okay, so already we have import here the NumPy library, pandas library, and sklearn impute is used to import the simple imputer class. Okay, so this library we have used to import the simple imputer, and using this simple imputer class we can fill the data. Okay, now here some attributes are necessary that I'm going to tell you. The use of simple imputer class has the below strategies. One is the missing values. Okay, so missing value, the missing underscore values, that is a one parameter placeholder which has to be imputed. It means by default the value is a NaN. Okay, so in missing value, we by default value is a NaN, but instead of that, if you want to keep something else, is there any constant value you want to fill, then you can fill. By default it's a NaN, but if you want to give any another missing value, then as a placeholder, then you can use any. Like if I want to keep 99, then I can give missing values colon 99. So wherever we find the missing value, then it can be input with the 99. Okay. Now the second is a strategy. So the data which will replace the NaN value from the data set. So which will replace the data. So here, sorry, in missing value NaN is there, that will be replaced with this strategy. The strategy which will be contain the mean value, median value, then most frequent value and the constant. Okay, sorry, I did a mistake. In missing value by default is a NaN. It means NaN is there. Wherever we find the NaN, that will be replaced by the strategy value. And in strategy, there is a mean value is there, that will be replaced by the mean value, median value, most frequent value and the constant value. So whatever the method we have seen, we can fill the data with the constant, we can fill the data with the mean, we can fill the data with the median, we can fill the data with the most frequent, that is nothing but a mode. So these all the things are possible with the simple imputer class. Okay, now fill value, there is a third argument, that is the constant value to be given to the NaN data using the constant. So if you are selecting strategy here, this fourth one constant, then which value you want to give here? So here in constant value, fill underscore value, you have to give the any constant number. So three attributes are necessary. One, in missing underscore values, by default NaN is there, so it check that is there any annual value is there. Okay, in strategy we can define the strategy for the replace the value. Okay, so if your strategy giving a mean, then it will take the mean value of all the data. If you are taking a median, then it will take the median of the features. Most frequent, that is nothing but a mode, and the fourth one is a constant. If you are selecting a constant, there is a third argument is there, fill underscore value, which will be filled by the any constant value. So whenever it give the NaN, the data using the constant will be filled. Okay, now let's go ahead with this. These are the libraries, are important library that we want to use ahead. So that's why we have to import NumPy, Pandas, and there is a one more library, that is a sklearn.impute, that we have to use, that is scikit-learn. Okay, then we have to import the which class? Simple imputer. Now whenever you have a data, your data will be in a two type. One is a training data and another one is a testing data. Okay. Now, what do you mean by train? Your data will be divided into training and testing. So here I have a two file which is already available. So training data is there and testing data is, both the data are available. Normally, if we have a one file, we can divide our data into the 70% and 30%. 70% will go for the training and 30% will go for the testing. Okay, but I have both the type of data, train and test. So I am just reading, getting here the train and test file of a house prediction data. Okay, so that will you can get from the Kaggle also, and I will share it into the folder also. So you can later on you can run it and check it. Okay, so we have used the data frame pd.read_csv. We read the file, training file, and store into the data frame name as a train. Okay, like that we can read the test data also and store into the test object, data frame object. Now we can check the shape of the train and test. So see here, shape of the train data is a 460, 81. It means 81 columns are there. And shape of the test data frame for test data shape is a 159 and 80. One column is not there because the target, we have a two type of variable, independent variable and dependent variable, or dependent variable is also called as a target variable. Okay, like I want to predict if I have a IQ features, then percentage features, and based on that I can predict the package of a student. Okay, so which are become my independent variable? IQ and the percentage. And third is package is become my target variable, because based on the IQ and percentage we can predict the value of the uh, package. So what happened here? Just a minute, I will write here. So if you are clear about it, then you can understand. Okay, let's IQ. Then second is we can say IQ. Then second column is the percentage, and third column we can say the package. Okay, so these are my data. Okay, I have a data like this. IQ is a 20, percentage is a 60, then he will get the 5 lakh package. Okay, IQ is a 45, percentage is a 70, 78, then he will get the 7 lakh package. Okay, like that. IQ is a 10, percentage is a 75 something, and he will get the 6 lakh package. Okay, so these are my data which is available to me. So these are my independent variable, IQ and percentage. These are two are my independent variable. Based on that, package will be assigned. Okay, so that is my, these are the three variable. From that, these are two, it's an independent variable, and this is my dependent variable, target variable. So target variable is totally dependent on this two variable. So what is done? These are my training data. It means if IQ and percentage is this, then package is this. If 45 and 70, 80, 45 IQ and 78% is there, then package is a 7. So these are my training data. So training data contain 3 columns: ID, percentage, and package. But when I am doing a testing, okay, so in testing, only you are giving IQ and percentage. Package is not given. Okay, packages will be predicted. Okay, package will be predict. So in test, you have to give only IQ and percentage. So only 2 column you have to give, and it will predict what is the package. Okay, so that's why when you are giving the training data for the learning of a machine learning model, for learning purpose you are giving to the machine learning model, you have to give all the data: ID, percentage, package. Based on this data, machine learning model will learn. And when you are giving the testing data, in testing data, ID and percentage is there. And based on this learning, the model will give you a predict the package of a particular person. Okay, so that's why when we are in training data, one more column is there, that is a package. Okay, so 3 columns are there, but in testing only 2 columns are there. Okay, so that I want to tell you. So see here, when we are checking the shape of the train, there is one more column, that is our target column is included here. But here in test, one column is less because target column is not there. Okay, so that I have shown you. Now train dot head, it show the first 5 rows of the so this is my target column, sales dot price. Okay, so that is included in the train data. So 5 rows, 81 columns, head is there, so 5 rows are there. Otherwise, total columns are, rows are 1460. Okay. Now, let's see what we have to do. 81th variable given, okay. Now we can do what? In train data, there are total 81 column are there. Okay, so 81th variable given to the white train. Now we are dividing our data into the training and testing. Okay, so what we are doing in training, we can drop the sales price. So that I am dividing. So here drop sales price, it means X underscore train will contain only 80 data. we are giving our training data to our model. So what we are doing, first we are dividing our training data. Okay, so we have to divide our training data. So from that we can remove the target variable. So we drop here the column sales price. Remaining columns will be assigned into the X underscore train. Okay, done. Here X is capital because it is a metric. So normally we are taking X underscore train, in that X is a capital, while Y underscore train, which contain only one column, that is our target variable, that will be stored into the Y underscore train. Y is a vector and Y train is a output. Okay, so that is a vector. So that's why it is a small y we are taking. So when we are taking a matrix, you can make a capital. When we are taking a vector, you can make it a small. Okay, now check the training data shape. So we have divided our training data. In that we can divide the column. So 80 columns are goes to the X underscore train, and output variable, it means target variable, goes to the Y underscore train. Yeah, row remains same. Okay, sales price is there, so that is comes into the Y train, and whatever the value of sales train, all rows are comes into this. Okay, so we have divided our data. Now numerical missing value imputation. Now we want to add the fill the data in missing value in using the imputation class. Okay, so first we can do what? Only first we are taking the numerical data. Okay, so let's get the numerical column first. Okay, X underscore train dot select d types that we have seen yesterday, this function, include equal to integer 64 and 464 dot columns. It means it will give you the column name which contain only integer and float. It means numerical data, and that will be stored into the num underscore varies. Now when we display num underscore varies, it will show you all the numerical columns here. Okay, so it will show you this number of columns which are all are numeric. Okay, now in this column, first we check is there any null value available. So for that we have checked X train num underscore varies. It means these are the columns are there. Dot is null. It check is there any null value. If it is available, then do the sum of that. So we get lot frontage which have a 259 rows are there. Then this 8 means winner area, mass winner area, that is a 8, and this carriage year belt 81. Okay, these are the three columns which has a missing value. Three features have a missing value. So now we are using the simple imputer. Just you have to give here strategy equal to mean. Okay, so simple imputer, we are creating the object of a simple imputer, imputer underscore mean, and we are providing strategy underscore mean, that I have told earlier that you can give here mean, median, then constant, okay, and most frequent. So here when you are giving here the strategy underscore mean, see, so mean is by default method there, so mean many methods, so many methods are there, mean, median, mode. Okay, like you, if you want to give the constant, then you have to give the strategy equal to constant, and one more attribute, field underscore value equal to 99, that I have already told you. See, field underscore value, that is you have to give here, so that you have give here 99. So if you want to fill with the constant value, then you have to write like this. If you want to give with the mean, then you have to write like this. If you want to write a median, then you have to write, instead of mean, you have to write the median. So first create the imputer mean object. Okay, now when you create the object imputer mean, there is a two methods are used, feed and transfer. Okay, now feed, it means you are giving your all the columns features to train your data, all the training data to learn. For that you are passing into the feed method. So all the training data you are passing into the feed method to learn the patterns or to learn the features. So here feed method get mean value from the data set. Okay, feed method is doing what? Getting the mean value from the data set and learn the all the features mean value. When you run it, it will show that simple imputer. It means all the this imputer will learn the data. Now check that they mean value of each and every column. Okay, so imputer underscore mean dot statistic underscore. When I write this, it will give me the mean value of each column. Okay, so whatever the columns are there, for that, for each column they are giving the mean value. This is the mean value of first column, this is the second, third, means whatever the numerical columns are there, these are the mean value of each columns. Okay, now whatever the mean value we have got through the training of data, that we want to transfer to the data. Okay, so that we are transferring to our data. So imputer underscore mean dot transform x underscore train numVars. So this mean value we are transferring to the train data. First we have learned the data, feed the data, from that they learn the mean value. Now we are transferring that mean value to the data. Okay, so now whatever the data we have transferred, that will give you a two-dimensional array. Okay, so two-dimensional array it will give. Now what we have to do, we have to translate our data into the data frame format. Okay, but then so this we have got the we have feed the mean value into the columns. Now, extrain dataset update with the transform dataset as well as same time impute to test dataset. Now, what we are doing here, imputer.mean transform extrain numVars. It means we are transferring to the train data also, and we are transferring to the test data also. So whatever the method learns, whatever the machine learning algorithm learns, that will pass to the train data as well as to the test data. So that will be update. Now mean value is filled. Now check here, is there any num value is there in a training data? No. See, there is no any null data. Is there any null in a nums test data? Then check here. There is no any null data. Okay, so you can fill like this. This is a simple way. You can use mean, median, mode. Instead of mean, you can write median and also do the same procedure. But this is for the numerical data. Now, what about the categorical data? Okay. So if you have a categorical data and in that is a missing value there, then what you have to do? Okay, so first you have to identify which are the categorical data are there. So first fetch the data which are the categorical. So in x underscore train, select the D types, include equal to O dot columns. O indicate the object type. Okay, so whatever the columns have an object type, that will be fetch and shown here, and that will be stored in a cat underscore wheres. When we write this, it will be shown here. Okay, now we have to check these are the categorical variables have null value or not. Okay, so that we can check. This is our data frame name, cat underscore wheres. It means these are the columns. Is null. If it is null, then do the summation of that value for the each and every column. So here see 1369. So null value is there. Here 870 null value is there. Here in this column 37 null value is there. 38. Like these are the column which has a missing value, null value. Okay. Now here when you want to apply mean and median is applied to numerical value, while for categorical data, mode is applied. Mode, it's nothing but a most frequent value. So here, in using simple imputer class, you can provide strategy equal to most frequent. Okay, so that's why most frequent, it's nothing but ultimately it is a mode. So you can provide the most frequent class, categorical class will be impute as a instead of a null value. Okay, so here we strategy use the most underscore frequent. Suppose you want to give the constant, then you can give here like this, but it is for the integer, but you can give here any unknown, like that type of constant you can provide into the categorical data. Okay, now we can run our object of a imputer class. imputer underscore mode. So it will give the strategy. It will check that which strategy you have given, that is a most underscore frequent. So object is created. Now, whatever our train data is there, x train cat underscore variable. So there's all the variables which are a categorical variable, that x train data will be fed into the our imputer object. It means your data will be key for the learning purpose. Okay. Now check all the modes of a statistics. All the statistic, it means which are the categorical values are there. In earlier there is a mean value, but here which are the frequent values we have got, that we have to check here. Okay. Now all the category variable has a which frequency. So first column, which is a categorical variable, which has a RL is a frequent value. In second column, PAVE is the frequent value. In third category column, GRVL, that is a most frequent value. Fourth for REG, regular, is the frequent value. Like that, it find out the most frequent value. Okay. Now, whatever the value we have got, that you want to transform. It means give to the our training and testing data. So for that, we are using the which method? Transform method. Okay. So whatever the value we have got here, that we are passing to the transform method for the training data as well as for the testing data. It means that frequent value we are passing to our training as well as the testing data. Now we are check, is there any null value? We have already passed, all the data are fed into that. Okay, so now check, is there any null value? No. For the testing also it will check, is there any null value? No. Okay, and you want to check with the summation, then you can do one more time sum. So like this, you can use the imputer class to impute the value into the missing value. Okay. So here we are completing our data cleaning step, pre-processing step. We have learned 3 practical session. One, data cleaning with deleting the rows and columns. We have done the data cleaning with filling the value using the mean and median. And third way, that is we have do the data cleaning after, with the imputing the value using the scikit-learn. Okay, scikit-learn library, and with the numerical and category variable we can fill here. Okay, so this is the thing we have. Data processing is completed here. Now we have to go for the scaling process. Okay, now let's learn about what is scaling. Okay, so just a minute. Okay, what is feature scaling? Okay, first we have to understand what is feature scaling. Let's see here with the one example. What do you mean by the feature scaling? Here three we can say the features are there. Okay, male height in a feet. Okay, so here there is a height is given of a male, and that is in a feet we are giving. So the unit is a feet. Now female height in a centimeter. Height of the female is given, but that is the unit is a centimeter. And lifespan in a year. So lifespan means what is the lifespan of a male and what is the lifespan of a female is given here in a year. Okay, so unit of each and every column or feature is different. The first feature has a feet, the second feature has a centimeter, and the third feature has a year. Okay, so here feature scaling is applied for this thing. Okay, so whatever the, so see, if we are considering what is the range of this height, if we are observing this 4 value, then the range of height is, we can consider from up to the 8.5. Okay, 0 to 8.5, for example. The range is 0 to 8.5 because right now 4 data are there and minimum value it's a 8, let's 7.9, and it's a maximum is a 8.5. So that is a range between this. Now, if we can consider this centimeter range, the minimum is a 140 and maximum is a 170. So that is the range 140 to 170. Here we can consider then 30 is a minimum and 41 is a maximum. So 30 to 41, it's a range. Okay, based on this four data. Now all the range are different. This is in a float, and as well as the range is different. Here the range is different, and here the range is different. Now, so feature scaling is doing what? All the data should be come into the same range, make into the same range, smaller range between 0 to 1. So it may be a height that will be converted into 0 to 1 scale. It may be a centimeter that also will be converted into 0 to 1 range, and it may be a year that also will be converted into the 0 to 1 smaller scale. So that is the task of the feature scaling. Let's go ahead. Okay, let's read. Feature scaling is a method to scale numeric feature in the same scale or a range. Okay, feature scaling is a method to scale numeric feature in the same scale or a range. It means whatever the numeric features are, that we are making that numeric feature in each and every feature in a same scale in a small range. Like for example, it's -1 to 1 or 0 to 1 that I have told you earlier with the example. Okay, this is the last step involved in data pre-processing and before giving to the ML model for the training. Okay, so this is the last important step of a data pre-processing. Okay, because after this we can give our data to the model for the training purpose. It is also called as a data normalization. Data normalization, it means you are keep your data into the same range. You are dividing, you normalize your data, distribute your data into the same range. That's why it is called as a normalization. If you remember the statistical Bell curve is there, that is called the normalized data. Okay, so that is, you can consider feature scaling is used for the data normalization also. Okay, we apply feature scaling on independent variables. I have given you the example which are the independent variable and which are the dependent variables. So normally on independent variable we are applying the feature scaling. We feed feature scaling with train data and transfer on train and test data. It means first we have to apply this feature scaling to the train data, and after applying on the train data, we can transfer on the train as well as the test data. Earlier in practical, we have seen the same thing. We have first applied the imputer class on a train data, and then after that we have transfer on the train as well as on the test data. Okay. Okay, why feature scaling is required? Okay, so the scale of row feature is different according to its units. That we have seen that here the height is in a feet, here the height in centimeter, and here the year is in a this one in a year. Sorry, this is a in a year. So every unit is different. So the scale of row feature is different according to its units. Okay. Now, machine learning algorithm can't understand feature units, understand only numbers. Machine learning is doing what? When we are giving this data, it only understands the numbers. It can't understand that is which unit is given to you. It understands only the numbers. Now, if height is 140 centimeter and 8.2 is a feet. So now check that 140 centimeter is higher or 8.2 feet is a higher. So normally if we are applying our knowledge, so 8.2 feet is a higher compared to the 140 centimeter. But when machine learning is algorithm is learning this, what happened? ML algorithm understand because it understand only numbers. So it can consider 140 is greater than 8.2. It cannot check it a centimeter or a feet. Okay, so machine algorithm is doing a mistake here. It will consider 140 is greater than the 8.2. This is the problem arise when we are giving data to directly data to the machine learning model, and this type of problem should be arise. So that's why when different units are there, the different scales are there, with different range is there, then we have to convert our data into the same scale in a smaller scale between 0 to 1. Clear? Done here? Understand? Again, I am repeating because it's an important thing. What is feature scaling? Scale of row feature is according to units. Okay, why it is important? Machine learning algorithm can't understand the units. It understand only numbers. When you are giving the data to the ML model, it give only the it take only the numbers. Now, in real life, what happened? Height is a 140 centimeter, and also it will be in a feet also, so 8.2 feet. So normally 8.2 feet is a higher compared to the 140 centimeter. But when you are giving a value to the model, this two number to the model can understand, ML algorithm can understand that 140 centimeter is greater than the 8.2. So it will make a mistake here. Okay, so that's why feature scaling is required, and we have to scale our features in a one range from 0 to 1. Okay, these are the different type of feature scaling techniques are there: min-max scaler, standard scaler, max scaler, robust scaler, quantile transformer scaler, power transformer scaler, unit vector scaler. Okay, but we are going to learn about mainly two scalars are used: min-max scalar and standard scalar. Min-max scalar, it means normalization, and standard scalar, it means we can say the standardization. Okay, so min-max scalar and standardization we are using this two scalar class. Now, see here one example. This is our row original data sets. Interest rate is there, employment rate is there, and S&P 500 price. Okay. Now, if we are going the quick statistic, describe function is there. Okay. If you want to take the describe, use the describe function, then it will give you some statistic regarding information. Okay. So for this data set, count value is 1000 for all the features. Mean is 2.20, 56.25, 2320. Standard deviation is different. Minimum value is different. Max value is different. Okay. So this is the statistic for this data set. Okay. Remember this thing. Now, I want to apply the normalization scaling here. Okay. So see here the different range is there. Mean value is different for the first feature, second feature, and third feature. Like the standard deviation is different for each and every features. Max value is also different for each features. Okay, so minimum value is also different for each features. So there are two techniques are used for scaling. First one is a normalization. Okay, so normalization is doing what? To it conducted to make feature value range from 0 to 1. So normalization is a one type of scaling technique which make a range from 0 to 1. Now this is the equation for the normalization. Xdex equal to x minus mean of x, minimum value of x, divided by max value of x, and minimum minus minimum value of x. Okay. So using that, you can change the range of your original data into 0 to 1 for any feature, for any column. Okay. Now, this is the just, we can go through the practical also, but right now just so scikit-learn provide the pre-processing package. In that we are library. In that we are using the min-max scalar for the normalization. So this class is there. Just create the object and feed and transfer your training data to it, and it will learn automatically and change the range of any feature into 0 to 1. Okay. Now, this is the normalization is conducted to make feature values range from 0 to 1. This is my original data set charts are there, and these are the my after doing the normalization charts are there. Okay, so this is the original range, we can say like 150 to 3. Here the range is 40 to 70. Here the range is 1800 to 3000. Okay, now after doing the scaling, range is changed for all the data. See, 0 to 1, 0 to 1, 0 to 1. Okay, so all the data's range is changed, even though see there is a no difference after doing the scaling. Okay, in your data before scaling, whatever the data are there, whatever the ranges are there, Okay, these are the chart. It is just for the visualization purpose, for the understanding purpose. Okay, but after scaling, when you applying the scaling and you generate the chart, there is no changes done in your data set. Okay, so you can do the changes. So ML algorithm work properly and give the better result. Okay, now when you change your after doing the scaling, check here in normalization, minimum value for the each feature is 0, 0 and 0, and maximum value for the each is 1, 1, 1. So your data lie between the minimum and maximum value. That is called the normalization. That is the scale of this minimum. All the data lie between the 0 and 1. Okay, let's see here the example. Normalization, this is the equation. Okay, these are my data. Randomly, I have taken 3 or 4 data, randomly selected value. This is the average value. This is the maximum value of that features column. And this is the minimum value of that column. Okay, so from this table, we are taking some of the data here. Okay, so we have taken this 4 randomly, average data, maximum, minimum, and we are keeping this value to convert our original data into the scale data into the range of 0 to 1. We are keeping value into this equation. Now check here. X, it means any value you are taking here. So we are taking first 22606 minus minimum of X. So minimum of X is a 1800. In that data, the minimum value is a 1800. So that we have minus, then divide by maximum of X. It means that feature maximum value is a 3000. So that is 3000 is here minus minimum of X, that is again 1800. When we count the value, it will give you 0.338. So original data is 2206. When we scale using the normalization, it will convert it into the 0.33. Okay. Now take the second one, average 2319 minus minimum 1800 divided by maximum 3000 minus 1800. It will give you the 0.43. Again, it will be coming to the 0 to 1 range. Okay. Then when we are taking maximum value, 3000 minus 1800 divided by 3000 minus 1800. So it will give you what? 1. Okay, the same value is that. That's why it's give the 1. When we are giving a minimum value 1800 minus 1800, it will 0. So all the product is come to 0. So it is the 0. So this is for the just showing you that all the data lie between to 0 to 1, and this we are confirming with the minimum value that will be a 0 converted into the 0, and maximum value that will be converted into the 1. So whatever the numbers you are getting, that is range from 0 to 1 after the normalization. So like this you can do the scaling. Okay, now second method is called as a standardization. Okay, second method that is called, it is called the standardization. So one method is a normalization, another one is a standardization. Now it is also used for the scaling purpose. Again, it will convert the data into the 0 to 1. But here in earlier, it will be convert the range 0 to 1. 0 it's a minimum value and 1 it's a maximum value, right? Here standardizing is conduct to transform the data to have a mean of 0 and standard deviation of 1. It means your data will be converted into 0 and 1 range, but 0 it's a mean value, average value, and standard deviation should be a 1. Okay, so the range is remain 0 to 1, but 0 it's a mean, MEAN, that is the average value, and standard deviation that should be a 1. So range is remain 0 to 1. Standardization is also known as Z-score normalization, in which property will have to behavior of standard normal distribution. See, this is the curve of a normal distribution. Your data should be distributed in a normal form. So the bell curve is there. This is your mean value and this is your standard deviation value. Okay, so your data will be live between this 0 to 1. So we can scale the data, we can minimize the range 0 to 1, smaller the range using the standardization. So this is the equation of a standardization to convert the scale range from 0 to 1. X minus x bar divided by the standard deviation. And this is the practically we can use the which scalar here, standard scalar. In earlier min max scalar, here in standardization it used the standard scalar. Okay, and then create an object and we can transfer our data using the fit and transfer method. Now, this is again, I am showing you visualization that before scaling, the range is different. After scaling, after doing the standardization, the scale is different. Okay, that is, we have a mean of 0 and standard deviation of 1. See, here it will see, this is our data, calculation data, but see, original data have a mean value. Average value is a 2.20, 56.25, 2320. Standard deviation value is 0.24, 4.86, 193.85. But after doing the scaling, the mean value, after doing scaling with standardization, the mean value is become a 0 and standard deviation value is become a 1. Okay, after scaling. So how to do the scaling? Standardization using this equation. We can keep the value. These are the 4 random value we are taking. 2206 minus x bar. X bar it's nothing but a mean, that is a 2319 divided by standard deviation is a 193.8 given here. So using that you can convert your 2206 into the minus 0.58. That is comes into the 0 to 1 range. That like that 2319 we are keeping 2319 minus 2319, it's become a 0. Okay, so that value is become a 0. Then 3000, that is a 3000 minus 2319 divided by 190, that is comes here the 3.513. We have not done around here. And 1800 minus 2319, it will give you this value. Okay, now now here you have to check. Now after the standardization, the average is set to the 0. So average should be, mean is become a 0. The upper value can be changed, but mean is remain 0 here. Okay, so this is the standardization. Using that, you can convert the range. Mean should be a 0 and standard deviation is become a 1. Okay, now before going further, we can go with the encoding technique also. Okay, so let's continue with the theory of encoding. Then after I will show you both the practical for the normalization, standardization, and the one hot encoding and all that. Okay, now what is one hot encoding? Okay, so let's learn here. Okay, one common challenge in machine learning is dealing with the categorical variable such as colors, product types, or location, because the algorithm typically require the numerical input. Okay, so one solution is this through one hot encoding. Okay, what it's saying that I am going to tell you, like we machine learning algorithm only understand the numerical data. Okay, now what happened if we have a categorical data? So categorical data we also have to convert into the numerical data, so that we have to deal. Okay, so there are lots of categorical data are there, like color is there, red okay, red color, green color, blue color is there, so that we are going to convert into the numerical. Okay, now so this is the method one hot encoding, label encoding, ordinal encoding. These are the encoding method which you convert your categorical data into the numerical data. Okay, so this is the first technique, one hot encoding, that is used for to convert your categorical data into the numerical data. Let's see. One hot encoding is a technique for representing categorical data as a numerical vectors, where each unique category is represented by a binary column with a value of 1 indicate it's present and the 0 indicate it's absent. Okay, let's understand first. Like this is the color which contain 3 class, red, green, and blue. Okay, now if I want to convert this into the numerical, then what happened? This red will be become a 1 column here, green is become a column here, and blue is become a column here. Okay, and where the red is present, it will give right here the 1, and in another one it's written the 00. When green is present, so in below the green it written 1 and other one 00. When blue is there, it written blue, below the blue it's 1, other one is a 00. Like that you can convert your categorical data into the numerical data. Okay. One more example we are going to learn here for the one hot encoding. See here. Just a minute. Okay. Now see here, this is a one example. There are some features are given here. Columns are there, total underscore bill, tip, sex, smoker, day, time, and size. Okay. Now the total bill is a type target variable, and these are all are the independent variable. Okay. Now if we consider because this is work on a numerical, the model is work on a numerical data. So if we consider only 3 columns are a numerical, total bill, tip, and size. And these are the 2 independent variable, tip and size. And this is the target variable. So can we remove this sex, smoker, day, and type? Is there any correlation of this data with the total bill? That we have to check. These are the categorical data, so we can't give to the ML model, that we can't do. Okay, we have to check the correlation is there or not. It means they are important or not. So first we have to check, like normally the male are paying more. Okay, male are paying more in the hotel. Okay, so male is also necessary for the bill. Okay, so that column we cannot remove. Smoker, those who are smoker, they have a more bill. Okay, so that's why smoker is also necessary. Day, if it is a Sunday, then we are going on in a hotel, so total bill is giving a more. Okay, if it is a Saturday, then like that we can consider the day also for generating the bill. Okay, then dinner and lunch, so time is also important. It is a dinner or a lunch, so that is also important, so we cannot remove this. Okay, so what we are doing, in we want to convert this categorical data into the numerical data, then we have to do what? We have to convert into the numerical data like this. We can do what? Whatever the classes are available, like here 2 classes are there, female and male. So we can make here one column female, another one is a male. Okay, so wherever female is present, write here 1, and male is there, then 0. Here male is there, so here in below male write 1, here 0. Here male is there, then below male write 1 and 0. Like that you can create for each and every column. Like in smoker, for example, yes and no there, then create here the 3rd column yes, 4th column no. Here no is there, so below no it's a 1, and for yes 0. Like for the day we can create Sunday, Monday, like that. For time you can create like that. Okay, so you can create, sorry, you can create multiple columns and then encode the value. So whatever your data, categorical data, that will be converted into the numeric, and then you can give it to the your model. Okay. Now, label encoding versus ordinal encoding. Now, what do you mean by label encoding? Okay. One is a one hot encoding. It will convert like this. Okay. Another one is a label encoding and the ordinal encoding. Now, what label encoding is there? Now, we have learned 2 types of data earlier. In categorical, there are 2 types of data, nominal and ordinal. Okay. So nominal, it means some labels are there, but all labels have an equal priority. No one is greater, no one is less compared to the other one. And ordinal encoding, it means labels are there, but one label is greater than the compared to the another label. So that's why we are giving order to them. Okay. So this is based on that. So label encoding apply on ordinal and nominal categorical variables. Okay. So label encoding, where we are giving a label encoding, it means when we are converting our categorical data, label data into the numerical format. So see, this is a label encoding example. Grade, the values are entered like A, B, and C. And object is laptop, car, and mango. Okay. Now see here. Label encoding is doing what? It will check the alphabets. If it is A, it will give a value 0. If it is a B, it will convert in, give the value 1. If it is C, it will give the value 2. It cannot check the order here, that A grade is a more important than the B is more important than the C. No, they are giving a numerical value based on the alphabet. See in a object column, laptop, car and mango. So based on the alphabet, it gives 0 to the car. C is there, so it gives 0 to the car. Then laptop is there, L is there, so it give 1 to the laptop, and mango is there, so it give 2 the mango. Okay, but here one problem is arise. If it is a nominal data, if there is no any order, then it's okay. Like in laptop, car and mango, there is no any order is there. Even though it look like that car is more important than the laptop, sorry, mango is more important than the laptop is more important than the car. Okay, so this is the label encoding is given like this, but still some problem is arise because yeah, if it is there is a no in this, it create a problem. Okay, because it show that it is a order is there. Okay, let's see here ordinal encoding, then I will tell you. In ordinal encoding, apply on ordinal categorical variables. Okay, so see here, A, B, C grade is there. So A have a more important, so they have give the order here through. B have a more important, they can give a order to 2. And C have a more important, so sorry, A have a more important, so 3, B have a 2, and C have a 1. So based on the order, they have assigned the value. Okay, so that is ordinal category. But here in label encoding, there is no order. They are giving a label to the alphabets. But when they are giving through the alphabets, again it's create a problem. It show that B is a more capable than the A, C is a more greater than the B. Okay, so that's why when you have to check, it's a label encoding, you have to check that do you want to convert it or not, it's a nominal or it's a ordinal. Okay, now see here. This category have a clear order when PhD represents a higher level of education than the master degree, which in turn is higher than the bachelor degree, and so on. In this case, label algorithm can effectively capture the original nature of the data. So see here, it show that when you are converting a data, so it show that PhD have a higher capacity than the master degree, master have a higher capacity than the bachelor, and bachelor have a higher capacity than the 0. Okay, so here we have learned all the theory regarding the scaling and all the things. Now we are going practical. Okay, so let's go to the practical. First we are going with the normalization and just a minute. Okay, normalization and standardization scaling technique. That I have told you, normalization and standardization, why we are using whatever our data are there, they are in a different range. We have to convert into the smaller range using the two techniques. One is using the normalization, another one is the standardization. So what they are doing, they are converting our the range into the small range, that is a 0 to 1 range. Okay, so normalization, that they are converting in a mean and max. Mean remain a 0 value and maximum remain a 1 value. In standardization, mean, that is average is 0 and standard deviation is remain 1. So that is the scale is done. For normalization, mean max scalar is used, and for the standardization, standard scalar is used. Okay, so let's see here the practical of a feature scaling. Okay. Now, so feature scaling we can do with the both the techniques, standardization and normalization. So for that, whatever the necessary libraries are that we are going to import here. First, import pandas that we need. Import Seaborn for the, showing some graphically visualization. We use the Seaborn. Now, Here for the standardization, the scikit-learn pre-processing library is there, and from that we are using the which class? Standard scalar class for the standardization. Okay, and one more scikit-learn pre-processing is there, library. In that, one more class is there, min-max scalar. So min-max scalar is used for the normalization process. Okay, so these two are the scaling class, standard scalar and the min-max scalar. Standard scalar is used for the standardization and min-max scalar is used for the normalization. Okay, now when we want to split our data, okay, into the train and test part, then for that we have to use the standard scikit-learn dot model underscore selection library. From that we are using the which class? Train test split class. Okay, so for that, when we want to divide our data into the train and test, then we have to use this library. So we have imported all the 5 libraries here. Okay, now we have taken the one data set of a Titanic. Okay, that you everyone know that Titanic data set is there. So that we are going to use here in this example. Okay, now let's first learn df equal to pd dot read underscore csv. We are reading our Titanic data set. Okay, and we display here using the df.head that we have already seen. So df.head, which will display the first 5 row of your data set. So it will display the 5 row. Okay, now here survive, these are the data set: passenger id, survive people, parent, p class is there, passenger class, the name of the person, sex, age, sibling, spouse, parent, child, ticket, fare, whatever. So these are the data are there. Now we want to work here only categorical data. So we are not working on whole the data set, but we have find out some numerical data first. Okay, so here survive is the dependent variable. Okay, that is our target variable, and others are the independent variable. So right now we have collected what? The 4 columns data we require. Okay, so all the numeric data are there. So first we identify the numeric data: survive, p class, age, and parent, child. Okay, and we have take, so this is see fancy indexing. Whatever the column we need, that we are passing here as a list, and that will be converted into the data frame, and that will be assigned to the new data frame as a df2. So this 4 column only we have get here. df2.head, head by default give the 5 rows. So these are the 4 column we have get here. Okay, now if any we can fill if any null value is there. Here only 5 rows are displayed. If we display all the data, then some null values are also there. So we can fill the null value using the mean. Okay, so we can do df2.mean. So it will find out the mean value of all the features, and then fill that df2 with the method fill na. It means wherever the null value is there, fill na is giving what? Null value. We can wherever the null value is there, it can fill with the mean value. Okay, so fill na is a filling the null value, but using what? We have pass here the mean. So using the mean, we can fill the null value and passing it to the new data frame, that is a df3. Okay, now we can divide our independent variable and the dependent variable. So let's see here. Our data frame have a total 4 columns. Now df3 dot drop. Which column we are dropping? Survive with all the rows. X is equal to 1. It means all the rows. So survive columns we are drop. And whatever the remaining columns are there, that will be stored into the X. So remaining 3 columns, which when P class, age, and parent, child, that is 3 columns are assigned into the X. Okay. So these are our independent variables stored into the X. Now, which one is a dependent variable? Survive. So from df3, survived will be stored into the Y. Okay. So that is our target variable. So first we have divided our data into the independent and dependent variable. Now let's check the shape of the x and y. So what is the shape? In x, 3 columns are there. Total row is 891. In y, only one column. One is not written here. It written only. So this is the structure of, it will be showing a tuple. 891 rows and one is by default. So they are not writing here, but one column is there in a y. Okay, so this is our independent variable. This is our dependent variable. Now we are dividing our data into train and test. Train and test, it means some data we are giving for the training purpose, some data we are giving for the testing purpose. So whatever x and y independent variable we are giving to the training also and for the testing also, and dependent variable will be also given to the training and the testing also. So we divide our independent variable in two parts, training and testing. Divide our dependent variable also in a training and testing. So for that we have import here one library, this model underscore selection, and there is a class train test split. So create the object of a train test split and pass here the 4 argument. X, that is our independent variable. Y, that is our dependent variable. Test size, it means whatever the data are there, that will be divided into train and test. So 20% part will be goes to the testing. And random state, that is for the, we have all seen the random state total 51 time it will done the division of data, okay, splitting of a data. So that's why it's take randomly. So you can change here the state 42 also and change accordingly. Okay, now so whatever the data are divided, that will be divided into the 4 parts. One, x underscore train, x underscore test. It means x underscore train, it means from this some data are going for the training purpose and some independent data goes to the testing purpose. Now in y train, our target variable, dependent variable, again it will be divided into a train and test. So some data goes to the y train and some are for the test. Now when we check this after dividing, that will check the shape. So see here 20% are goes to the test, remaining were on the train. So for dependent variable, 712 rows are goes for the training and testing 179 is good for the testing on an independent variable. Dependent variable 712 rows for the training and 179 is for the testing. Okay, so we have divided our data into the training and testing. Now we have to apply the standard scalar. Okay, so just a simple create the object of a standard scalar. Okay, so what is standard? And just a minute. Yes, we have just created a standard scalar. So what is the standard scalar is doing? It scales the data into 0 to 1. Okay, 0 is a mean average value and 1 is the standard deviation. So in between this range, they can do the scaling. So it learned the mean and standard deviation value from the trained data. So what is the standard scalar is doing? It learned the mean and standard deviation value from the trained data. Okay, so this fit method is doing what? We are providing our training data to the fit method, and this fit method learn the mean and standard deviation value from the trained data. Okay, now let's check SC underscore mean. So it display the mean value of all the features. So we have a 3 column. So first column mean value, second column mean value, and third column mean value. Okay, now if I want to display the standard deviation value, then what we have to write? Standard scalar object dot attribute name is scale underscore. So it will display the standard deviation value of all the 3 columns: 0.84, 12.99 and 0.79. Okay, now what we have to do? X underscore train describe. So describe will give you a statistic value, right? That we have seen yesterday. Okay, so it will give your training data set describe value is count is 712, Mean is 2.30, 29, and 0.30 for 3 columns. Standard deviation is 0.84, 13, and 0.79. This is a mean minimum value, and this is the maximum value. Okay. Now, so this is before we are transferring the value. This is the mean and standard deviation value. Okay. Now we are transferring whatever the data have learned, transform that learned data into the train as well as the test data. Okay. So, and don't need to scale on a dependent variable. We have to just transfer our independent variable data only. Okay. So we can, whatever the transform learn data into train and test data. So transform into the train and test data. So sc dot transform fit method we have used. Sometimes we can use fit and transfer both simultaneously. So there is a method called fit underscore transform that learn as well as feed the data after learning. Okay. So whatever they have learned, that will be transform here in a train and test data, and one more data frame we have created, that is x underscore train sc and x underscore test sc. Now check your data will be converted into the range or not. So x underscore test sc, it will give you a 2D array. Okay, and see the range. That is a range between 0 to 1. Okay, see, all the data are converted into the 0 to 1, but it is a 2D array, so we can't see properly. So we can convert our data into the data frame. Okay, so pd.data frame, pass your variable x underscore train sc, as well as we can convert the x underscore test sc. Okay, that also get the same array like this. Okay, now give the column name, p class, age, and parent child. Okay, to both the train and test data. And see here, x underscore train sc head. See, your data will be shown in a data frame format. Your range is, your data will be converted into the 0 and 1 range. Okay, earlier it was like this. Your original data is like this. This is a range is different, this range is different, this range is different. Now it will be in a same range. Okay, so that you have got. Now check the statistic. Okay, so this is the statistic after doing the scaling. Okay, if I am not writing here round 2, okay, this round 2, because our data, let's see, I have to run all the cell actually. Okay, if we are not giving round 2, it will give you a float because our data set has a float value. Okay, so that's why it gives the 2.30, 29.55 like this. But it is a float value, so we can round it. Okay, and now check the performance. See, your standard deviation is a 0, and okay, I have to run again cell run all. Okay, your standard deviation is in a 0, and it is in mean is in a okay. No, this one. Okay, this one. Here you have to write. See, the mean is become a 0 and standard deviation is become a 1. Because it is in a float value, that's why it is not giving a proper result. Float data set is there, so that's why we have to do into the round. So that's why it gives the 0 and 1. So now after scaling, you check your mean is a 0 and standard deviation is 1 for each and every column. So your data is scaled between this 0 and the mean 0 and the standard deviation 1. So this is, we have done standardization. Okay. Now we are doing the normalization. For normalization, instead of standard scalar, you have to use what? Min max scalar. Okay. Min max scalar we have to use. So here we are creating one object of min max scalar, that is MMC. Now whatever your trained data set is there, that you can transfer using the fit method. Okay. Same thing we have to apply, just we have to change here the scalar name. Okay, now run it. It learned the data. Now whatever you learn, whatever the data have learned, that you are transferring to the train as well as the test data, and create a new data frame. Now check the value after the transferring the data. So x underscore tram mmc c two-dimensional array is get, and all the data converted into the 0 and 1 range. Now convert into the data frame. So same thing we are applying, just changing this variable name. So this variable are changed here, and when we print the describe function, see here the standard deviation mean is 0.65 and standard deviation is 0.40. Sorry, here in normalization, we have to check the minimum value, min, mean 0 and max is a 1. Okay, don't check here the mean and standard deviation, because we are applying the what here, min max scalar. We are doing the second scalar type scaling method, that is a normalization. So in normalization, you have to check the minimum value 0 and maximum become a 1. So all the data will be converted into the 0 and 1 range. Okay. Now this is a pair plot, just for the understanding purpose. This is a pair plot for the X train data before applying the scaling. So your data is look like this. See. Okay. Your data normalization look like this, normalized data. Okay. Pair plot is showing a normalized data as well as scatter graph. Okay. Now this is after the pair plot we are giving after the standardization. So see, the same thing is there. There is a no, even though applying the scaling, there is no changes done in the data. Okay. And after applying normalization, see the same graph will be displayed. There is a no changes done into the data set. Okay. So that is good that we can convert your data set into the scale. Now your model will get the proper data and it will perform properly. Okay. Now, so scaling is completed. In scaling, we have performed two scalar. One is a min-max scalar, another one is a standard scalar. Okay. Now let's learn about the one-hot encoding and the dummy variable. Okay. So what is done in the one-hot encoding, that we have already understand. Okay. Categorical data will be converted into the numerical data using the one-hot encoding. Okay, and the dummy variables we can see. Okay, so let's learn about the one-hot encoding. Okay, first we have to import the pandas as PD. So we have imported the library. Now read the data. So this is the same data I have applied, which I have shown you in the example. Okay, so tips data is there. Okay, total bill is generated. Total bill is a target variable. Other one is a independent variable. So this data is shown here. The size of data is 244 rows and 7 columns are there. Okay, now generate the dummy variables. Okay, like we are generating the dummy variables. As I have told you earlier, that if one class has a one feature has a two, like sex, female and male, then the dummy variable, two more dummy variable is created. So for to create a dummy variable, we can use the pandas. One method is there. Okay, get underscore dummies, which will generate your dummy variable. So what is our data frame name? Tips underscore df. Okay, this our data frame. This data set are there that we are passing, and data type equal to integer. It means whatever the data are there, that will be converted into the integer. So now it create the dummies variable. Now see here what it did. We have a sex which contain female and male. So sex underscore female and sex underscore male is created. Smoker has a two value, no and yes. So it created two column. Day, Friday, Saturday, Sunday. So it created three, Thursday, so 4 column. Time, dinner, time, lunch. So these are the dummy variables are created here. Okay. And wherever the value is available, like in this female is available, so it's create a 1, here it gives a 0. Here male is available, so it give a 1, here 0. These are the dummy variable they have created as per the number of class, as per the categorical variable. Okay. Now, this is the syntax I am showing you when you are writing get underscore dummies. The syntax of get underscore dummies is this. Okay. So the data you are passing that we have seen here, we have passed the data. Okay. And data type equal to integer we have given here. Okay. So two argument we have passed. Now see here, data you are passing prefix equal to none. It means when you are converting your dummy variable, if you want to set any prefix, then you can give. Here by default, they have taken the column name as a prefix. Okay. Then underscore is there, prefix underscore separated, so that is underscore, and the another one they have taken the value. Dummy underscore NA equal to false means create a column and write one in row where NA and value is present. If you are giving this value false, okay, by default it is a false, but if you are giving a value true, then wherever you get the null value, okay, it will give you the write one in row where the none value is present, but that we have not set here. By default it is false, so it is not taking any value. Then columns equal to none. So number of columns to create the dummy variables. Like if you want to restrict 4 columns only create the dummy variable, so you can write here the 4. Okay, here whatever the categorical data, all the columns are created. Sparse equal to false means we don't, if you want to create a sparse matrix, then you have to give here the true. Here we don't need, that's why I don't need to write here the true. Then drop underscore first false. It means k minus 1 dummy variable. Okay, that I am going to show you how. And d type is a none. That is, if you want to give an integer, then you can give like that. Earlier we have given. Now drop underscore for first, that is here false. If we are giving the true, see, I am giving here pd dot get dummies, tj drop underscore first equal to true and d type equal to integer. Now see here, drop underscore first equal to true. It means there are two columns are there, sex underscore male and sex underscore female. Okay, but why we need two columns? Already if it is a 0, then male is absent. If it is a 1, then male is present. If 1 is there, then male is present. So why we need sex underscore females, then smoker underscore no? If it is already there, this by using this value, you can get the data, then there is no need to create a more features. Okay. So if you are writing drop underscore first equal to true, so it will delete one class dummy variable. That is a k minus 1 dummy variable. Okay. So it will automatically remove the. Otherwise, what happen if there is a categorical variable and there are 1,000 classes are there, then 1,000 columns are created and it will occupy the memory and it will affect your model also. Okay, efficiency of model also. So instead of that, you can use only one column because from the one column you can get all the details. Okay. Now one hot encoding with a scikit-learn. Okay, so let's do now one hot encoding. This is using the dummy variable you have created the one hot encoding. Okay, now if you want to create a one hot encoding with the scikit-learn library also. So from stlearn.preprocessing import the one hot encoder. Okay, so this is the class we have imported. Now create the object of a one hot encoder. Okay. If you don't want to make a sparse matrix, then you have to write here the false. This is the object of a one hot encoder. So OH underscore ENC, we have created the object. Okay. Now, if you want to drop the first, then you can write here drop underscore first also. Okay. So same like that get dummies method. Here they are using the one hot encoder class. We are passing here the sparse output false. So sparse matrix is false because we get the numpy array. Okay. Now, whatever this object is there, using that you can use a fit and transform method. See, fit and transform both are done simultaneously. Earlier we have used the fit method, then after use the transform method. Okay, but simultaneously some of the classes are provided both the method. They can do the both the method simultaneously feed the data also, and after that transform the data also. So whatever these four categorical variables are there that we are passing here for the learning purpose and for the transform purpose, and whatever the result are come, that will be shown here. So whatever the value are there, that will be converted into the 1 and 0, but it show in the two-dimensional array. Okay, so we have to convert into the data frame then after. Now dummy underscore df dot keys. Okay, now it will show how many columns are there. So first we can find out the all the columns. Now what I want to do, I want to convert the data frame. So pd dot data frame, and this value you have to pass here, and columns equal to, we are giving the name, because we have already created a column. I want to create a name, so that's why I have call here and then pass the, otherwise there is no need to write this code. I am getting this code from the earlier dummy one hot encoding method. Okay, because I need this name, that's why. Otherwise you have to write yourself sex underscore female, sex underscore male, whatever the name you want to give, that you have to pass here. So here we are giving the name of the columns, and we see that our data frame. Okay, so whatever the value are there, that will be converted into the numerical form, and where the value is present, it will give a v1. It is not present, then it will give a 0. Okay, so this is a one hot encoding which will convert your categorical data into the numerical data. Okay, one more method is there for the one hot encoding. Sorry, this is a encoding method. So one way is a one hot encoding and the dummy variables. So that we have seen, using the dummy variables you have converted your data, and using the one hot encoding you can convert your categorical data into the numerical variables. Now another two way are also there, label encoding and the ordinal encoding. Okay, let's see the example of a label encoding and the ordinal encoding. Okay, let's see here. This is the example for the encoding. So what is the use of encoding? It will convert your categorical data into the numerical data. We have already seen two methods. One is using the dummy variable. So you can create dummy variable. Okay. And second way, using the one hot encoding using the scikit-learn. We have done the one hot encoding using the dummy variable also, and using the scikit-learn also. Now we are going with the label encoding and the ordinal encoding. Just a minute. Just a minute, I have to start the Now, see here, now we are applying the label encoding and the ordinal encoding. We have already learned what do you mean by label encoding and what do you mean by the ordinal. So there are two types of categorical variable are there. One is a label and another one is a ordinal. Okay, so in label, the data, whatever the category, nominal and the ordinal, sorry. In a, there is a labels are there. Okay, now in ordinal, what happened? In ordinal data type, whatever the labels are there, they have an order. Okay, if you are liking this phone, so the phone is, for example, any product, then the product is excellent, good, poor, like that you can give the range. So for excellent, we are converting, when your excellent will be converted, so excellent have a more priority than the second one, good. So you can, when you are giving a number, so excellent have a some value 3, good have a some value 2, poor has a value 1. That is called the ordinal encoding. So when you are converting your class category, then class category have a some order numbers you have to assign. And in label encoding, what happened? You are converting like car color. So blue color, pink color, white color. Okay, there is no any there is no any order is there. Okay, So you can just give the number, but you have to check that that number has a ordering or not. So don't give any order, that meaning should be changed otherwise. So that's why label encoding is not work when the ordinal encoding is. So it is depend on your necessity of your project or work. Okay, so let's see a label encoding and the ordinal encoding. First, we have imported the pandas. So pandas as a PD, so that is a library we have to use because we need the functions of pandas. Then from sklearn pre-processing, scikit-learn pre-processing library, and from that we are import the label encoder. Sometime you can use the ordinal encoder also, label encoder. Okay, these are the different encoder. So label encoder, let's use it. Okay, now pd.sat underscore option display dot max underscore rows and none. It means if you want to see your whole data set, okay, like this, okay, you want to see the whole data, all columns and rows, then you have to give here the set underscore option. This is for the rows only. You can set for the columns also. Okay, now now read your data set. So here we are reading the data set. This is a house prediction data set. Okay, and df dot head, so it will display the first 5 rows. Okay, and 81 columns. Okay, I have not refreshed, that's why this thing is remaining, otherwise it will show the whole data. Okay, now let's see. Now from this we are only taking 2 categorical column. One is a kitchen equal and the building type. Okay, so from this we are taking, okay, it is not shown here because we have not shown all the data, but this 2 categorical variable we are using. Okay, not taking all the, but we are using 2 categorical variable, so that we have assigned the df2. Okay, so my new data frame which contains the 2 column. Now create the object of a label encoder. So first we are creating the label encoder object because we are using that class for the creating the uh, creating the numerical data. Okay, from the categorical. So label encoder we are using, create the object. Now again see, there is a label object and there is a method called the feet underscore transform. Again I am telling you there are 2 different methods are there, feet also and the transform also. Here the 2 methods are the combined method, feet underscore transform. Okay, so df2 then blog type. Okay, so what we are sorry, building type, sorry, building type we are passing here, and learn and transform to the label encoder. Okay, so whatever the data of a building type, they have converted into the numeric. Okay, so now they have, see, we can get the one array here, one dimensional array we are getting. Now, what I want to do, feet underscore transform building type, and we are assigning whatever the value we have get, that we have assigning into the one data frame, that is building type after the label encoding. Okay, and df2. So now see, now you can see the value instead of a array, you can get the value here. So building type, there are different type of categories are there. So they have given one FAM, 2, these are the categories are available in this data set. 2 FM, then duplex is there, one category is a twin. So these are the classes are available in this categorical data type. Now after label encoding, the value is assigned, just check who has a 1 in this class, they are giving a 0 value. Okay, then who has a 2 FM, starting with the 2 FM, that is assigning a 1 value. Then in duplex, they are assigning the 2 value. In twins, TW and SE, they are assigning the 4 value. Okay, like that, they are converting the your building type class into the encoding. Okay, so this is the one way label encoding. Using that, you can convert your categorical data value into the numerical data. So this is shown all the rows. Just a minute. Okay. Now built-in type, if you want to count that how many rows are there in each category. So 4 classes are there, 1 FM, TW, duplex, and these are the 4 to 5 classes are there. And value you want to count. So 1 FM, there is a 1220 value. 2, this is 114 value. Duplex 52, twins 43, and 2 FM con, that is a 31. Okay. So this is nothing but we are converting your this categorical data into the numerical data like this. They are assigning a number to the particular class. Okay. So this is label encoding. Now we are doing the ordinal encoding. Okay. Now that we are doing for the second kitchen quality feature or for the column. So here, first we can check kitchen quality value count. Okay. Here we are using the order encoding. So let's check how many categories are there. So one is a TA, good, excellent, and that is a FA. I don't know what is that, but that is average, something like that. So this is the these are the 4 classes are there, and this much of time they are repeating in the rows. This is the value of that particular class. Okay. Now, yeah, this is the explanation. EX for the excellent, GD for the good, TA for the typical average, and FA for the fair. Okay. So these are the 4 things are available here. Now they have written like TA for the small form of the typical and average, GD for the good, EX for the excellent, and FA for the fair. So this value are available in this column. Now what happened? We are doing the order labeling. So now what? Through the dictionary, we are doing what? For EX, we are assigning the 4. For GD, we are assigning the 3. For TA, we are assigning the 2. And for FA, we are assigning the 1. Okay. So we are giving a label to the each and every class. Okay. So we are assigning this 4. Now what we are doing? Now we map this order. Okay, so df2 dot kitchen quality dot map order underscore label. It means this order underscore label we are mapping with the kitchen quality column. And whatever the new data frame is generated after encoding. So what it did, wherever they find EX, they can write 4. Wherever they find GD, they can write 3. So they map like this. And one more data frame is created, new data frame is created, that is a kitchen quality data encoding. Okay. Now when we write df2, see kitchen quality GD. So where GD is there, it will show 3. TA is there, it will show 2. GD is there, 3. TA is there, 2. Like that, we can write here the data. So this is called your ordinal encoding. So you can do the label encoding as well as the ordinal encoding like this. Okay. So I have covered all the topics in this. So today what we have learned, so I'm just going through thoroughly and just repeated the things what you have learned today. Okay. So just a little bit faster, we can go through back and learn what we have done. So little bit faster, within 5 to 10 minutes I will complete. Okay. So first we have learned the life cycle of machine learning. Okay, so how the life cycle of machine learning works, we can collect the data from the different sources. Then the data, after trying the data, we will pass to the, just a minute, we will pass to the our data preparation stage. In data preparation, data pre-processing is done, like cleaning of data, filling the missing value. Then in feature extraction and engineering, we are generating the new features. Okay, and in feature scaling, what we are doing the whatever the data are available to us, if it is in a different range, then that we can convert into the small range. Okay, as well as we can do the encoding also. The whatever the categorical data are available, that will be converted into the numerical. So after this is the last stage, feature scaling is the last stage. After doing that, we can pass the data to the our model, machine learning model. Okay, because machine learning model only understand the numerical data. So all the things are done, then after we can pass the data into the our model, and model will evaluate by the training and testing data. If it is done properly, it will result give you accuracy. If it is not done properly, then again do the data preparation, again do the same process and pass to the model and evaluate the model. Okay, if it is done perfectly, then deploy your model. Okay, what is data pre-processing? In simple language, data pre-processing, it's nothing but convert your raw data. It may be in a text, image, video, and audio. Convert your raw data into the meaningful data using the different techniques. Okay, now these are the data pre-processing techniques: data cleaning, integration, reduction, transformation, and discretization. Okay, what do you mean by data cleaning? Data cleaning, it's nothing but whatever the null value is, missing value is there, then you can fill it with the any mean value or median value. Okay, data integration, it means you are getting the data from the different sources. Okay, like from the API, web scraping, and like that, in different sources and in different format, in CSV format, JSON format, like that. And you have to integrate all the data, merge the data into a same format. So that is the thing is called as a data integration, but you have to check that there is a correlation between that data. Data reduction, it means sometimes some of the data are not necessary, some columns are not necessary, features are redundant, sometimes it give a redundant features. So at that time you have to reduce that features. Okay, see here, country name and country code. If country code is there, then there is no need to for the country name, so we can reduce it using the eliminate that redundant data. Okay, then data transformation, I have the scaling is nothing but a data transformation. You can do the scaling if your data in different range. Okay, it may be in a year, one column is in a centimeter, one column is a feet. Okay, so your data is in a different unit and in a different range, then you have to convert that data into the same scale between 0 to 1. So scaling, there are two type of scaling: normalization and the standardization. That is the same technique you can use here in the data transformation. Okay, then data discretization, that is nothing but you can convert your numeric data by mapping value to the in a particular interval. So you are making a grouping of a data using this technique, so that is called the binding. So here data are there, you can keep into the small interval. Okay, so now feature engineering, feature, it's nothing but a property of your independent variables. For example, I have given example of a car. Car has a color, model. Okay, so that is a property. Engineering, it means you are solving some problems and do some innovative work. That is called the engineering. So here, what we are doing in feature engineering, to create a feature from the existing data. Okay, based on your knowledge, you can create a data from the create a new features from the existing, and that which will improve the performance of the machine learning model. Okay, now this will skip. Okay, this is some example of a feature engineering. These are the existing features, and from that we are creating the new features. Okay, then variable, which is a one type of characteristics, number and quantity that we have seen. Okay, there are different types of variable are there: numerical, categoric, dates and time, and mixed. Numerical, there is a discrete and continuous. Discrete, it's a nothing but an integer variable. Continuous, it means float. Categorical, in that there are two types: ordinal and nominal. Ordinal, in that you can give the order to the variable. Categorical, it means the value is in a label format, and that label has an order or not. If it is an order, then it is called the ordinal, and if label has a no any order, then that is called the nominal. Okay, date and time variable is there, mixed variable. Okay. Then we have learned about the missing values. Okay, if we got this, so these are the techniques of the data pre-processing, cleaning data. So there are different methods are there for cleaning the data. So you can clean the data using the removing the row and delete the row. Okay, so here if data is not there, then you can remove that row. Okay, but this is not a proper thing, because when you are going with the removing the data, if it is a more 5% data or missing data, then you can delete, otherwise don't go with this method. Missing value manually based on the observation, you can check and fill that. If it is a 34%, then you can keep here p. So manually you can keep the value, but if data are in lakhs, you cannot do the manual work. Global constant, it means some constant you can fill the data with some constant value, 0 and unknown, like that. Then you can fill the data with the mean median mode. Okay, so take the average of this value which is available and take the mean of that and fill the missing value with the mean value, like that. You can fill the data with the median also. When you are working with the we can say the numerical data, then you can go with the mean and median, and when you are working with the categorical data, then you have to use the mode. Then mean median mode for each class. Okay, so you can take the mean of the Java class and fill the data. Sorry, whatever the Python is there, so Python class, average of Python, and then fill the data, like that. If is there any Java missing value, then take the average of the Java and fill with the mean. So for take the mean median mode for the each class. Then using the ML algorithm, this we have seen the practically also. Imputation class we have used and fill the data. So you can use some ML algorithm, and using that also you can fill the data. So whatever the data available with us, we can give it to the training the model. The algorithm will train the data, learn the data, and then based on that, it will give the data and which we can fill for the missing value. Okay, feature scaling. See here, feature scaling. Here the one column is in feet, another one is a centimeter, and the life of a year is in a year. So the range is also different. This is a range from 8 to 9. This is a range from 100 to 200. This is a range from 1 to 100. So range is also different. So when you are giving the data to the model, so what happened here? 140 centimeters. See, this is a good example. 140 centimeter and 8.2 feet. Which one is a greater? Normally 8.2 is a greater compared to the 1.140 centimeter. But machine learning understand that 140 is a greater than 0.8.2. So that's make a problem here when the units are different and range are different. So that's why feature scaling is doing what? It scale your range into the smaller range, like -1 to 1 or 0 to 1. And for that, there are mainly two techniques are used: normalization and standardization. Okay, that we have learned. Normalization, in that they have scaled the data between 0 to 1. 0 and 1. Minimum value is 0 and maximum value is a 1. That is done in a normalization, and min-max scalar is used for the normalization. Okay, minimum 0 and maximum 1 value. So you can convert your range into the 0 and 1 value, minimum 0 value, max 1 value. And standard scalar is there. In standard scalar, whatever the data are there, that will be converted into 0 in 1 range, but 0 mean average. Average is 0. MEAN, 0 average value, and standard deviation is a 1. So standard scalar is used for the standardization. Okay, this is the example and the equation. Then encoding method we have learned. What do you mean by encoding? We have a numerical data are there. Machine learning already understand the numerical things. Okay, so if we have a categorical data which has a label like color, product type, locations, like that, city name. So what we can do? In that case, categorical data can't understand by the machine learning algorithm. So they can convert your categorical data into the numerical data. So for that, encoding method is used, and in encoding there are different methods are there. One hot encoding, label encoding, order or encoding. These are the different encoding methods are used. What one hot encoding is used? One hot encoding is doing what? They are creating whatever the labels are there, that is created as a column, and if the label is available, it will give the 1 value. If it is not, then it will give the 0 value. Like that, one hot encoding is work. Label encoding, Label encoding normally is doing what? It work for the there are two type of categorical data, nominal and ordinal. Nominal data, it means labels are there. So when label encoding is work on a nominal data, it will doing what? It will give, label encoding is work like a based on the alphabet. So it will give a 0 to A, B to 1 and C to 2. Okay, like here it give a 0 to C because it works on an alphabet. Okay. So like this label encoding work. Ordinal encoding, which is only apply only on ordinal category. Label encoding apply on a nominal data also and on the ordinal data also. See, in the ordinal data also and the nominal data also. But it give the number based on the alphabets. Okay. But one problem is arise. Why problem is arise? Because A has a greater value compared to B. But when we are giving this, then it will misunderstand. Okay, so that's why ordinal encoding, when you want to give a ordinal, you have ordinal data, then you have to use the ordinal encoding. Apply on ordinal categorical variable. So here A, B, C, that will assign 3, 2, 1, and this is like these are the nominal data. So there is we are not assigning, just for the understanding purpose we are giving the other example. Okay. So this is the whole summary of today's lecture. Now I have conclude here. Ma'am. Yes, sir. Done from my side. Now, is there any query? Then you can ask into the chat box or in WhatsApp group. I will reply in the WhatsApp group also. So you can write down in the WhatsApp group. And if you have any query or if you want to connect me with, any day, you can, if you want to learn something more, then you can contact me on this email ID. I am just giving you. This is my email ID, so you can contact anytime. Okay, through the mail.
Wait a minute, ma'am.
Yes.
Okay, good afternoon everyone. This brings us to the end of third day of our STTP. A sincere thank you to Dr. Meghna Madam for her continued support for delivering two highly practical and insightful sessions, as well as to all participants, faculty members and students for your active engagement throughout the session. Have a great day ahead. Thank you everyone.
Thank you. Thank you,
Thank-
Riya ma'am. Thank you, Prantav sir, for your kind support
Oh,
and inviting me here. Thank you.
okay, I am ending the meeting now. Thank you.